Mr. A here with you. Today we're looking at volume of tapered solids and spheres. We'll be going through some examples together. I'll give you the formulas, I'll show you how to use the formulas, and we'll have a look at some trickier questions that you may come across. And hopefully, once you watch this video, you'll be on your way to answering any question you have or that you're given about volume of tapered solids and spheres. So let's get going. First of all, what we have here, we're starting with a cone. We've looked at cones before, we've looked at surface area of cones. We're going to find the volume of them now, so how much space there is inside that cone. Now if we relate this shape to an actual shape that we may find in the real world, the best example I can give you is basically an ice cream cone. Okay, so if we turn this upside down just like that, there's your ice cream cone, and your ice cream would sit nicely on top of there. And we'll have a look at an example a little bit later on that kind of relates to that. So let's have a look, as always, let's have a look at what we need to know about this cone before we can get going. Okay, so the very first thing that I'll do is I'll write down the actual formula for it first, and then we'll have a look at what all the different parts of that formula mean. Okay, so our formula here looks something like this. So pi squared times capital H. Okay, so as always, when we're looking at these formulas, we have special letters. The R stands for radius, capital H stands for height. So if we look at our cone there above, these parts you'll find just here. So again, the radius is from the midpoint of a circle out to one side. Okay, so that's our radius there. And the capital H here, the height, is how tall this cone actually is. Okay, so the actual height, there's two ways you can represent it. You can go from, let's say, the base here all the way to the tip. So you can say that that's your capital H, okay? Or you can also represent it in the middle here. So from the very, very top, we can draw a dotted line going all the way down like that, and we can give that a capital H there, okay? So it's from the very bottom of our cone to the very, very top. Alrighty, so there's our formula. Make sure you copy it down, make sure you have it somewhere in your notes, highlight it, whatever you must do with it, okay? Like always, when we're dealing with circles, we need to use that pi, so anything with circles in it needs to have pi involved in there, okay? So that's our formula. Let's have a look at a quick example here. If we move on to this middle shape, let's plug in some random numbers. Let's say 3 centimeters, and let's call our height, let's say that's, I don't know, 9 centimeters. Okay, so we're dealing with volume now. We're going to find how much space there is inside of this cone. Now, like always, first thing we need to do is work out what shape we're dealing with. Okay, easy question there. We are dealing with a cone. First thing that I want you to do is always write down the formula that you need to use. Okay, so our formula is V equals a third pi r squared capital H. So there's no times in there. If you look at the two formulas, compare them, I've got the multiplying signs in there, the times. You don't need to write them down because it's what you do in algebra. Basically, they become invisible. So we've got down our formula. Next up, we need to take the numbers from our cone and substitute them into the formula. So let's have a go at doing that. Let's see what we have. So volume equals 1/3, that stays the same, doesn't change, times pi, pi doesn't change, stays the same, times our radius. We need to figure out which one of these numbers is our radius. Now, like we know from other videos and other examples, the radius is from the center of a circle out to one side. Okay, and in this case it's 3 centimeters. So we have 3 squared times our height, and our height, we can see here, our cone is 9 centimeters tall. Okay, so that's what we have there. Next up, what we need to do is plug these numbers into a calculator. There's our calculator. Let's line that up nicely. So what we have, a third. You can do this as a decimal if you'd like. I prefer you use fractions, so you do 1, then you find your ABC button, which on this calculator is right there. All right, 1/3 times pi times 3 squared times 9. Okay, so you just plug the whole thing in just like you've written it down on your paper, hit equals, and you get an answer of 84.82 don't forget your units, centimeters, and we're using cubed here because we are looking at the volume of a shape. Okay, and that's our final answer. That's how much space, 84.82 cubed centimeters of space inside of that cone there. Okay, so that's one quick example. Again, we'll have a look at a trickier example when we move on in a second. Now, next shape that we're looking at here today, we have our rectangular based pyramid. Okay, and that's it there, you can see it right there. What we need to know about this is obviously the formula. So let me just write down the formula for you here quickly. Times width times height. Okay, so that's our formula. That's one we need to know. Let's run through those three things that we need to know about our shape. All right, the 1/3 stays the same, and the reason we have a third at the front, so if we go back to the cone here, let me just explain why we have that 1/3. We have a third because these cones and pyramids take up basically exactly 1/3 of the space of a cylinder in the case of a cone, and exactly 1/3 of the space of a prism when we're talking about our pyramids. Okay, so that's why we have 1/3 at the front there. Okay, going on with our rectangular based pyramid, we have the 1/3 at the front, that stays the same. The length is the longer side, which in this case we'll call that one, all right, at the front. The width is basically the same thing as you'll find on a rectangle, so the length and width. And the capital H there, the height, again, is how tall our pyramid actually is. Okay, so it's the two ways you can show this. You can either show it from the very tip there to the middle of your rectangle down the bottom, or you can also show it on the side. You might see it in some questions, they'll do it like this, from there to wherever the base may be, there. So we can call that H, or we can call that one H there. Okay? So the H is basically how tall your pyramid is. So that's our formula. Again, copy it down, write it down. Let's have a look at a quick example using this formula to find the volume of a rectangular based pyramid. Let's bring in another page here. There we go, there's our next little rectangular prism. Let's plug in some numbers. Let's say 4 centimeters. We'll call this one 6 centimeters, and we'll call our height, let's say it is 11 centimeters. Okay? So, going back to what we talked about before, again, the very first thing you need to do is work out what shape you're dealing with. Okay? We've worked out it's a rectangular based pyramid. First thing I want you to do is write down the formula that you need. So we have V equals 1/3 length, width, and height. Again, I've made those multiplying signs or times invisible there because we don't really need to have them. Makes it look neater. Next up, second step, we need to substitute the numbers, figure out which one of these numbers is which on our shape. Okay, so let's label them first. We have our length, we talked about before. The length is going to be at the front. Okay, the width on the side, and the height is how tall it is. Okay, now really it doesn't really matter what order you put those numbers in, but it's nice to label the sides. Okay, so now we take those numbers and substitute them into our formula. So we have V equals 1/3 times the length, which we said was 4, times the width, which we said was 6, times the height, which we said was 11 centimeters. Okay, once we've done that, again we bring our calculator into play and we start to write those numbers in. Let me put this on the other side here, just like that. So again, you substitute or you plug those numbers into your calculator. You have 1/3 times 4 times 6 times 11, and you hit equals, and you get 88. So we have 88, don't forget your units, centimeters cubed. Remember, it's cubed because we are dealing with volume. Anything with volume is going to be cubed. Okay? And that's our final answer for this one. Nice and simple stuff. Let's move on to something a little bit different. Again, we're looking at a sphere. We've looked at the surface area of spheres before. Now we're going to look at the volume of spheres. So, let's have a look at what the formula looks like for this sphere. Now again, because we are dealing with a circle, we need to have that pi there. And there it is. Okay? Always have pi when you're dealing with the spheres. Alright? So, the 4/3 stays the same. You don't change that number at the front. The pi just a button on your calculator. We need to know the radius of this circle, so again, of this sphere, sorry. So again, the radius is from the center of our circle, or in this case our sphere, to one side. Okay, so we can call that one R. And that's all it is. That's our formula. That's where you find your radius on your sphere. Okay, so let's have a look at a quick example on how to work out the volume of our spheres. So let's give this sphere a radius, sorry, let's call it 7 centimeters. Okay, and we're asked to find the volume of that sphere. So again, the first thing I want you to do, work out what shape you're dealing with. We know it's a sphere. Write down the formula that you need to use. Okay, step by step. So we have volume equals 4/3 times pi times our radius cubed in this case. Okay, so we got our formula. Now all we need to do is label on our diagram which one is our radius. We already know that, we've talked about it before. We know that the 7 is going to be our radius. Alright, so second last step, what we've got to do is substitute the numbers into our formula. 4/3 stays the same, pi stays the same. The only thing that we're substituting here is our radius, and we know that the radius is 7. So it's 7 cubed. Okay? We bring in our calculator again into view. There it is. Just set up a little bit differently. There it is. And we start to plug in these numbers. Again, 4/3, you can do it as a fraction if you want, but I suggest you keep it nice and simple and do it as a fraction. You can do it as a decimal as well. Okay? So we have 4/3 times pi times 7 cubed, and you'll have a cubed button on your calculator there. Okay? And we press equals, and that's our answer. So we get 1,436.75 centimeters cubed. Don't forget your units. So there we have a nice simple example on how to work out the volume of a sphere. So what I want to do next is just quickly go through 2 examples that you might come across either on tests or in your textbook or just in your an exam or something like that, where what they like to do is actually mix and match shapes. Okay, so what we have here, first up, we look at this shape first. We can see that we have a rectangular prism there on the bottom and a square-based triangular prism on top. Okay, so we need to find the volume of the whole thing. Alright, so what I suggest you do is you start nice and simple, nice and easy, and you take it step by step. First of all, let's write down the shapes that we have. Okay, so shape number 1, we'll call this shape number 1 down the bottom here. We have our rectangular prism, and you can even draw a little picture just so you know what shape you're dealing with. Okay, and there it is. So with our rectangular prism, let's work out how to find the volume. So if we think back to our volume here for this rectangular prism, volume equals length times width times height. Okay, going back to our diagram, let's label these 3 parts. Alright, so we can see that the base here, the bottom of our rectangular prism, the length at the front is 10, so we can call that our L. Now you'll notice that all of these 4 sides are the same length, they're the same size. So if that's going to be 10 centimeters, all the others are also going to be 10 centimeters. Alright, so our length will be 10 centimeters, our width will also be 10 centimeters, and the last one that we need to know is our height, and we can see that on the side here, we can see how tall it is. Alright, so there's our H, or our height. Now all we need to do is substitute these numbers into our formula. So we have 10 times 10 times 25, and if we plug that into our calculator, we get a number of 2,500 centimeters cubed. Okay, so there's our answer for shape number 1. But are we done? No, we're not, because we still have that square-based pyramid on top. Okay, we need to work out the volume for that one as well, and we've just done that at the beginning there. We need to, again, if we can just set this up and draw what picture we're working out, the triangle at the top, the pyramid at the top. First thing we need to do is write down the formula. Alright, we talked about the formula before. We have 1/3 times length times width times height. Okay, so let's label it on our diagram here. If we go back up the top, which one will be our length? Well, our length we talked about before is at the front here, so we'll call that L, and our width of that square, it's the same size, just like the square at the base of this rectangular prism down here. So our length and width are going to be the same, and the height, they give us how tall our pyramid is. Okay, so our H will be right there. So now we go back to our formula and we substitute these numbers into it. So we have 1/3 stays the same, times length, which is 10, yeah, times our width, which is 10, times our height, which is 12. Alrighty? And again, we plug these numbers into our calculator and we get an answer of 400 centimeters cubed. Alright? We're one step away from finding the final answer. Now, we have the volume of our rectangular prism down here. We have the volume of our square-based pyramid at the top. All we need to do now is add those two answers. So we'll just put a 2 in there. Okay. So all we need to add, or all we need to do now is add the volume of the rectangular prism to the volume of our pyramid. Okay. So step number 3, we need to do 2,500 plus 400, and we get a final answer of 2,900 centimeters cubed. And this will be our final answer. Okay? And we can give that a big tick. So that's what we've done there. We've worked out the volume of the shapes independently. Okay? And then at the end, we've added these two answers. Okay, so that's how we work out one of these composite or more trickier examples or questions. You use the basic knowledge that you have about how to work out volume, and you add your answers at the end. Okay, let's have a look at one other example here at the top. So again, we have, like I said before, we have a cone down the bottom, and this time it's been filled with a scoop of ice cream. Okay, and you can see the scoop on top of there. We know different parts and lengths of our shapes. What we need to do is start to work them out independently first. So we need to work out the volume of each shape independently. Work out the shape, or the volume, sorry, of the ice cream on top, and work out the volume of our cone down the bottom. Okay? So let's start off with shape number 1. Shape number 1, if we look at it carefully, what we have is basically half of a sphere. Okay? So we write down the actual formula for a sphere. So our formula for a sphere is 4/3 times pi times the radius cubed. Okay, that's the formula for a sphere. Next, we figure out what our radius is from our question above. Now, if we look carefully, we are given the length of the whole circle. So from one side of our sphere to the other side. That's called our diameter. All we need to know is half of this, from the middle to one side. Okay, and to do that, to work out our radius, we simply divide this number in 2. So 6 divided by 2 is 3 centimeters. Okay, now we can work out the volume of our sphere on top, and there's a little trick to this, which we'll get to in a moment. So when we substitute those numbers in, we get 4/3 times pi times 3 cubed. Okay, and when we plug these numbers into our calculator, we will get an answer of 113.09 centimeters cubed. Now, this is where the trick comes in. This answer here that you've got is for a full sphere. Okay, so it's for basically a full sphere, a soccer ball, or a full cone or full scoop of ice cream. In our example here, we have half of that, and we can see we draw it on the side here. We have half of a sphere. So we need to divide this final answer by 2, okay, because we only have half of a sphere. So when we divide that answer by 2, what we get is 56.5 centimeters cubed. And this is the actual answer, our final answer that we use for the volume of our ice cream scoop on top here. Okay, this 56.5. Very important to keep an eye out for the half shapes like this. Alrighty? So, we've worked out the volume of our scoop of ice cream on top. Let's work out the volume of our cone on the bottom. Okay, so again, we write down the formula that we need to use for our cone. There it is there. And we can go back and label what part is what. Okay, so we need to know the radius. We've already worked that out. The radius is 3, so we can label that as 3 if we want to. Okay, and we need to know the height. And the height is given to us here as 11 centimeters. So all we need to do now is substitute those numbers into our formula. So volume equals 1/3 times pi times the radius squared, and we know the radius is 3, so it's 3 squared times 11. Okay, and when we write these numbers into our calculator, when we plug them in, we get an answer of 103.67. Don't forget our units, centimeters cubed. Okay, so we've got our answer for the volume of our half scoop of ice cream on top, and we've got our answer for the volume of our cone on the bottom. Now what we need to do simply is add these two numbers together to get our final answer of the volume of this whole shape. Okay, so step number 3, what we need to do is do 56.5 plus 103.67. Okay, and when we add those together, we get 160.17, cross that out, centimeters cubed. Alright, and there's our answer for the final volume of that shape there at the top. Okay, so again, what we've done is we've broken this big shape into 2 separate shapes. We've worked out the volume of half a sphere on top. That's what we've done there. Then we've worked out the volume of our cone down the bottom, and that's what we've done here. And finally, our third step, we've added the 2 answers together. All right, and there's our answer of 160.17 centimeters cubed. We can give that a big tick. So hopefully this has helped you a little bit with understanding how to work out an example like this in a question like this, where we have one big shape. We obviously split it up into 2, just like we've done down here, and then just add up your 2 answers like we've done here. Don't forget to go to YouTube and subscribe to the channel, and also on teachertube.com. Until next time, I'm Mr. A.